Okay, good morning. Um, for today's lab, we are going to do 3 problems, try to draw, practicing drawing ER diagrams. And we will do some of the problems in class. I will probably show you the answers so that you could understand like the whole thing at least through examples, things like that. And then you have to turn in one of the problem by Friday night. Okay. So first I'll go over things that you have to do. There are 3 problems total. Um, the first problem is about the company database. Okay. So let's take a look at what the problem is. And if you have questions, understanding, um, let me know. Okay. Ready? Ready? Okay, the first one is the simplest one. We have to design a company database that need to store information about employees. So we have lots of keywords and hints for you. It says employees is identified by SSN. When you see the word identified by, so it means it's identifiable, so it's unique. SSN is unique, and also you have to put the salary and phone number as an attributes. Okay, so you sort of know that the employee is probably going to be an entity, okay, with SSN and salary and phones as attributes. So you have to decide which one would be the primary key for the entity. And then we have to store information about departments, again, identified by DNO, which is a department number. And we need to put extra attributes, which are department name and budget, right? And also the children of employees with name and age as attributes. Okay, so the first bullet will probably tell you what the entities would be. And then in the second bullet, it tells you in detail on how entities are interact with each other. Employees work in departments, and each department is managed by an employee. Okay, so this is somewhat similar to what we did in the lecture. And then a child must be identified uniquely by name when parent, who is an employee, is known. Okay, and we're not interested in information about a child once a parent leaves the company. All right. That means when parents leave company, a child could also be discarded. So we need to draw an EA diagram that captures this information. So what do we need in an EA diagrams? You need to put in the entities, relationships, and key constraints, like one-to-one, one-to-many, whatever. Is there any partial, total participation? Things like that. That's about it for EA diagram. This is the easy ones, straightforward ones, very similar to things that we did in class, just to make sure that you understand how it's done. And then problem 2, a bit more complex. So if you're done with number 1, you can move on to problem number 2. Number 2 is about art galleries. All right, so we need to create a database that capture information for the art galleries. So the galleries keep information about artists, the name, which are unique, okay, birthplaces, age, and style of art. And for each piece of artwork, an artist, the year it was made, its title, its type of art, whatever, and its price must be stored. Pieces of artwork are also classified into groups of various kinds. And a given piece may belong to more than one group. All right. And each group of artists is identified by name. Okay, like the group name. And then Gary keeps information about customers. For each customers, they keep unique customer ID, person's name, address, to the amount of dollars spent, and the artists and groups of arts that the customer tends to like. Okay, so given that we have this scenario, you have to come up with an E diagram for the database. If you need to put some assumption, you can write down your assumption and put the constraints accordingly. Okay, so that's the second problem that you have to do. And the last one, the third problem, is about the bike shops. All right, so given that we have like a small business, a bike shop by Amy, she will record sales on the printed form, which contains the invoice number and date of the sales and the customers, employees involved, whatever. So previously, everything was done on papers. So we're gonna transform those into like database. Okay. And then for each employee, so we have to keep information about the sales and the employees. And for employees, we have national ID number, the first name, last name, home phone number. And for each customer, we have to record customer ID, the first, middle, if any, and last name, and at least one phone number and at least one home address. Okay. And then to keep track of the product inventory, we need to record the number, the name, the price, quantity of the products in stocks. And for each product, we have a range of service that could be offered. All right. So also we have to list all the types of products and the charge for each service. Multiple types of service could be offered. Okay, to multiple products. All right. Also at different prices. So with this scenario, you also have to draw a diagram, a diagram for the database. Right. So there are 3 problems total. I will give you some times trying to tackle the problems, and I will go over the solution for at least problem 1 and 2, just to make sure that everybody is on the right track. And then you're on your own on problem number 3, and then you have to turn in diagram for problem number 3 in MyCourseVille before before midnight, Friday night. Okay. So yeah, you can start working on the problem. If you have question or whatever, I can go around and answer questions that you have. And for the quiz, we will have the first quiz next Wednesday at 9 o'clock. The quiz will be about this lab. So if you could do this lab properly, you should have no problem doing quiz 1 next Wednesday. For the EA diagram to turn in, you can draw the diagrams on paper and take a photo, or you can draw it on iPad or whatever. Or if you want to use tools to draw rectangles, things like that, up to you, anything, fine. You need to turn in by Friday night. Yeah, it seems like most people finished number 1 already. So let me go over things about number 1 and see if you understand things correctly so that we can move on to other problems. Okay. Then if you still have problems regarding number 1, let me know. You can ask like afterwards. All right, so let's recap on what we need to do for problem number 1. We have to look for keywords, right? Employee works in department. That means we need employee, we have department, and then we have verb like works in. And then it has a statement saying each department is managed by an employee. So this signifies something. That means that each department can have only one manager. We will not have, we're not allowed co-managers and all, because it says each department is managed by an employee, right? And a child must be identified uniquely by name, but not just that. This is not the end of the sentence. It says identified uniquely by name when the parent is known. So this statement is saying that a child cannot be a strong entity. A child by itself will not be identified uniquely. So if you want to be able to identify a child uniquely, you need to use the name of the child together with the information about the parents. So this will give you a hint that this has to be a weak entity somehow. Okay. All right. So, so this one will tell you that the key constraints on one side has to be one, like one employee, one department can only have one manager. Okay. And this part tells you that it's going to be weak entity. And the last one, it's just to add on information that we're not interested in information about the child once the parent leaves the company. That means this follows the effect of being a weak entity, that when the parent is gone, when the parent is deleted, all the weak entities, like the child, the dangling, everybody will be deleted as well. Okay, but if you have two strong entities, like a employee, which is a strong entity, and then a child, which also is a strong entity. So when the parent leaves the company, the child will still be there. Okay, because they're a strong entity, and unless you specifically delete them. Okay, but if you see something like this, that when you delete the strong entity, everything in the weak entities that connects to that particular items will also be deleted very easily. But you can force the DBMS not to do that if you want. But by design for weak entities, it's like that. It's like connected to the strong entity. All right. So this is a possible solution. You may or may not have this one, but this is not the end product just yet. Okay. Don't take a photo just yet. It's not correct. So first we have employee entity with SSN. This is the key. We have salary, we have phone number, we have departments, another entity with DNO, which is a key with department name and budget. All right. And we have to think about the key constraints, manages and department and works in, right? So right now, everything is left as many to many. So you have to think about, look at the requirement. We know that each department can have only one manager. So it has to be one on this side, right? It says nothing about having an employee being managers for multiple departments, right? So we can't make it too tight of the constraints. If it doesn't say, you have to leave it open, right? That means that you will probably allow employees to be a manager in multiple departments. So that leaves it to one to many, all right? And for works in, does it say about employing working in multiple departments or not? If it doesn't say, you have to leave it open for like it's allowed. And for each department, are we allowed to have only one employee in a department or many? So it should be many. So that's many to many. All right. And for the dependent, the child, we know that the child, if you design like this, name is a primary key, which is not possible, right? Because we know that name, we could have duplicates in name very easily. So if you design like this, it's not going to be a good design, right? Because you will quickly have some errors with duplicate names, right? So what do? We have to make it a weak entity. Weak entity is an entity that has no primary key of its own. It may have partial key. What is a partial key? Partial key is the key that when used together with the owner, or in this case, owner is employee, together, we can uniquely identify the items in weak entity. Okay, so for manages, we want to make it one to many. So depending on which notation you want to use, if you want to use the notation with the arrows, the arrowhead has to stick with the diamond. Okay, so this is one to many. Now, in terms of participation constraints, we didn't really have any specification in the problem. So you could make your own assumption, or you can use whatever assumption that you want. Definitely, this cannot be total, because it doesn't make sense to have all the employee being like everybody must be a manager, right? So you leave it as partial. But on the other side, for departments, if you assume that every department must have a manager, you will make this total. Okay. The same with works in. Works in is many to many, right? And if you assume that everybody must be working somewhere in some department, you will make this a total. And this also total if you assume that every department must have someone working there. Okay. So if it doesn't say, you try to make things as flexible as you could, but unless you have specific assumption, you write those assumption down, and then you could have your design accordingly. Now for the weak entity, we have to make sure that you write down the notation for weak entities properly. Some people only make it bold for the child, but not the diamond. If you do not bold the diamond, you have problems identifying who would be the owner of the weak entity, especially when you have a lot of connections. Right now, there is no confusion because it only connects to one strong entity, but you see later next week that one entity could be like one weak entity could connects to many entities, and then it would get confused which one is identifying ones. Okay, so making the diamond bold will tell you where to find the owner of the weak entity. So in this case, the employee is the owner of the child. So you could see that this has been changed to the dotted line, not the bold line anymore. Okay, dotted line saying that name is a partial key. So when you use the name of the child together with SSN, SSN is the primary key of the owner of the weak entity. So the strong entity, you have to take the primary key of that strong entity together with name. So we will be able to uniquely identify the child. Because we assume that for each parent or each employee, you will not name the child the same name. Okay, with that assumption. Okay, but in reality, this may not be true, especially would you name your child the same name? Okay, maybe the nickname. No, I don't know. Okay, or maybe if you change it to dependent, let's say, you could have lots of dependents. They may not be just your child. It could be your niece or whatever, whoever. But you could have duplicates in the name. If that's the case, you have to change your design accordingly. All right. So this is the final solution. Again, one possible solution for problem one. So if you have other types of assumptions, your design could be slightly different. Okay. And if you have question or if you have question about your design, like if your design really different from this, you can ask. Okay. We have one more TA coming. This is Pi Earn, Pi Pan. Okay. So they could help you. Yes. This one? Okay. So if we have assumption that every department must have a manager, you will make it total. But if you say that we could have some departments that need no manager, like we could leave it as partial, depending on your assumption. How do we know what? Oh, it's your assumption. So part of it, it will be given by the problem. So if it's specifically saying the problem, you have to follow exactly that. Other than that, you could, well, make reasonable assumption. Okay. Or if not, you can leave everything as flexible as possible, leave everything partial. It will be okay as well. Okay. Okay, so if, oh, sorry. Okay, you can move on and start working on number 2. Okay, number 2. Okay, for problem 2, let me give you like simple hints first, so that you could have a good start on it. Okay, let's take a look at the problem. We first thing we try to identify the entities and relationships. Which one should be entity, which one should be relationships, like that. So if you look at the requirement, somewhere that we need to keep information about the artist. Okay, and we have the name, and it tells you that the names are unique. So it tells you something that, oh, the name could be the primary key. Okay. And then we need to have some birthplace. We have the age and the style of art. So it tells you all the attributes and all. Okay. And we have artwork, which is, so we have artists. So the artists will create artwork. For each piece of artwork, we need to store what? We need to store the artist the year that the artwork was made, the title of the artwork, the type of art, and the price. These are things that we have to store for each piece of artwork. Okay. And pieces of artwork, we have to classify them into groups. Okay. So somehow we could we have to create some groups. And each group is identified by the name, like group name that describe the group. And then we also keep track of the customers. It tells you that it must be unique, customer ID. We have customer's name, we have address and total amount of dollars spent in the gallery. And also the artists and group of art that customer tends to like. Okay, so these are the main things that you should be able to draw out of these information. Identified all the entities that we need, and then relationships that connects the entities together. And then in other parts, you can look at the constraints, like one to many, many to one, whatever, like afterwards. But first, let's identify the entities and relationships first. All right. All right, let's look at number 2 and see if you're doing in like more like a right way. We already looked earlier at the entities and relationships. Now we look at the constraints. Even though we didn't really explicitly say in the problem, we could assume that each piece of artwork has to be painted or created by an artist if you want to, but if you do not want to assume this, that's also okay. Okay. So we assume that each piece of artwork was created by one artist. Okay, that's my assumption, but you could have different assumption if you want. And we could also have several pieces of artwork with the same title. Okay, right? That's also very possible. That means that the title itself should not be the primary key, because you could assume that, let's say you have a piece of artwork called The Morning, something like that. So we could have a lot of artists that paint the morning differently. Okay. Okay, so what are we going to do with this? Now let's take a look at the entities first. We have the artist, that's the main one, the artist, and identified by name, that's the primary key. We have birthplace, style, and age as well, the problem says. And then we have artwork. And the title is not the primary key, because we could assume that we could have duplicates in the title across different artists. So title has a partial key. So artwork by itself will be a weak entity. Again, we have to have the year, the type, and the price. The weak entity that connects to artists. So given that, if we use the title of the artwork along with the artist's name, we should be able to uniquely identify the artwork. Okay, given that one artist will not have a lot of artworks with the same name. That's our assumption. But if you have some artists that create artworks, 5 artworks with exactly the same name, this design has to be modified to take care of that. Right. So in this case, artwork is weak entity. Make sure that you bold the artwork box and also this diamond to make sure that we know exactly who the owner of artwork is, the strong entity. So in this case, the artist is the owner. And the artwork can be classified into groups. Okay. We can see that classify is not bold. So we're saying that artwork, even though it is a weak entity, its owner is just artist, not the group. Okay. We can just connect artwork to groups as usual. We don't have to care whether it's a weak or not weak because we already know the owner of artwork. And then we have group. According to the problem, the name is unique. The name of the group is unique. So it is a strong entity. And the customer, we have customer, it doesn't really say how we could like make customer unique. So one way is you could create a new attribute, customer ID, make it unique. Or if you want, you can, we have, yeah, you have to create another one, make it unique. Because name, last name together, we cannot guarantee that it will be unique anyway. Okay, so we have the name of the customer, we have address and the amount of dollars that they spent there. And then the customer will like two things, like a group and like artists. Okay. And for all of those, it doesn't say anything about how many groups or how many artists customer can like. So we would leave it as many to many. Okay. In both ways. So this is many, 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 many. Each group can be liked by many customers. Each artist can be liked by many customers, of course. And for classification, artwork can be classified into many groups, and each group will have lots of artworks in there. So everything is many to many. And I want to emphasize one thing about weak entity. Make sure that it is one to many and total on the weak side. So here we have the arrow saying that this is one, this is many, and then this must be total. Because if this is not total, some artwork will get lost because we don't know who the artist is. Okay, so that's one possible solution. That. Now the last one, the last problem, you will have to turn in your solution for lab 1 by Friday night. Okay. But if you don't want to like do anything like after today, make sure you can do it, get it done today and turn it in. It's not very difficult. All right. Okay, for this problem, well, the one that you may have questioned about is about the products and services. So imagine if you have a bike shop. So you are selling a lot of stuff there, like lots of parts, like products. And you can just go to the bike shop and buy the products. That's also fine. Or you can take your bike and get a service there. For example, you could go there and change the tire of your bike. So in that case, you have to buy the product, the new product, and you have to pay for some service to change the tire. So that's the services that you could offer as well. And all the services will be connected to the product. Some of the service may require lots of products to get that service done. So that's the whole thing. Okay, so let's start doing this. If you have questions, well, can ask.